Hey, what's up people? Welcome back to LeoNative. Today we are going to talk about something that makes a big difference between juniors and seniors developers. And it's not about knowing more libraries, but about avoiding mistakes that affect performance and user experience. The interesting thing is that many of these mistakes are not only made by juniors, but also by seniors. They just don't notice that they are hurting their art. So, in this video, I will show you 5 common mistakes in React Native, why they happen, and how to fix them so you are feel smarter and has a better chance to be approved in the stores. You are creating a product list, in this case 50 items, with a filter input at the top. The user types product and the app starts to feel slow, maybe even drops frames. Here we have the list and we open React DevTools profiler. We see that on every key press, the whole list renders again. The filter changes one value, but all 50 components render. Many devs think, I wrapped my card with React Memo, so it should only re-render when its product changes. In theory, this is correct. In practice, no. When a parent component render, every inline function is recreated, even if the value is the same. The JavaScript reference is new. Consider this line. On every render, this arrow function is a completely new function in memory. The same happens with render item in FlatList. If its reference changes, the list recalculates everything. It should not render on every key press, only when there are real changes in the list. We achieve this by making sure items only render when the props really change. Memorize on press with use callback. Memorize render item. Just use memo for filtering. This avoids unnecessary re-renders and keeps the list smooth. Additionally, if we use FlatList, we can consider some extra props. You have an app that uses sensor, for example the accelerometer. User report that over time that app becomes slower or even crashes when navigating between the screens. This is a silent memory killer. Here we use the accelerometer and simulate a fetch that get data. We open React DevTools profiler and we say that every time we navigate between screens, memory use increases. This is not very exact, but it gives us an idea. Two different leaks saying useEffect. Most junior developers understand that useEffect runs side effects, but they don't always understand that useEffect with an empty dependency array also needs a cleanup function for every resource it accesses. Two types of leaks usually happen together. 1. Unreleased subscriptions. accelerometer, location, Bluetooth, WebSockets, push notification, all of them register a callback in a native system. This callback keeps a reference to the component state. Without cleanup, the native system keeps sending events to a component that is no longer active, and JavaScript cannot free that memory. 2. Set state on unmounted component. You go fetch user profile, it takes 3 seconds. At second 1, that user goes back. At second 3, the promise resolves and tries to call set state on a component that no longer exists. In some cases, React show a warning in development, but in production, this becomes a silent memory leak. Every time we navigate, memory stays stable or decrease because subtractions are cleaned up. We achieve this by saving the subscription reference and cleaning even the return of the useEffect. For fetch, check if the component is unmounted and use abort controller to cancel pending requests if the user changes screens. Your app works fine in Expo Go, but in production users say it is slow. You check and you find many console.log, even one that runs every frame in your AR screen and another logging user tokens. Here we can see log printing user tokens, large object from an API, and we simulate a button that acts like a frame. In AR, we use the term FPS, usually 60 FPS. This is like having 60 logs per second. Might versus reality. Mic. Console log in production is invisible, so it doesn't matter. Reality. Each console log does 3 expensive things. Serialize data, large object becomes JSON string, crosses the bridge, interacts with native, allocates memory, creates garbage for GC. Tools like Sentry or Crashlytics may capture log. If you log tokens, emails, or API response, the data can go to external server. In a normal app, you may not notice it. In AR at 60 FPS, one console log inside a loop can drop it to 30 FPS. Log in production can go to unexpected places. Log should exist only in debug. When pressing the frame, nothing should appear in productions. One way to do this is to create a helper to manage log and check if we are indexed. Metro remove it in production. So, log only debug, no log per frame in production, if needed, use condition to show log only in depth. You build your app using an iPhone 17 simulator and it looks perfect. A user tests it on iPhone SE and the header is too big. Another user on Android with Notch, the layout breaks. We ran the same screen on two emulators, Pixel 9 Pro and Pixel 6. We can see the top padding is different and bottom has no padding. Using a fixed value like padding talk 44 doesn't work for all devices. Each phone have different space because of Notch or System UI. Spacing looks correct on all devices, both top and bottom. React Native themes recommends and React Native Sapphire context. We can configure it globally in the root files, in our case, layout.js. Then use inset to apply correct padding top and padding bottom based on the device. UR is simple, not much media, just a few screens and simple logic. Everything looks like until you build it. The result surprises you, almost 100 megabytes. You inspect the bundle and find a real problem. You are including full libraries but using only one or two functions. Here we have libraries like Lodash, Moment, and a utils file. Lodash, for example, is over 70 kilobytes, Moment 60 kilobytes per language. We are importing the whole utils file but using only one function. Importing all functions and properties from a library means you also include all its weight, even if you use only one function. Visually nothing changed, but code size is smaller. We import only what we need. We can also create our own small functions like capitalize or replace moment with .js if we only need simple features. This also applies to our own file like utils. Import only the function you need instead of the whole file. By the way, the extension to see package size is import cost. It is not 100% exact, but it gives a good reference. And this is important because in large apps, the difference is not kilobytes, it's become megabytes. And that's it. 5 mistakes that look small but make a big difference in performance and user experience. The difference between junior and senior is not how much code you write, It's how well you understand what is happening behind the scene. If you apply these changes, your app will be smoother, use less resource, and give a better experience. Subscribe and see you in the next one. And remember, stay hungry, stay coding.